Harvard says aliens, NASA says comet. In the case of 3I Atlas, the scientific world is split in two. 3 weeks after its discovery, debates erupted across observatories worldwide. NASA and the European Space Agency called it clear, a comet, natural origin, physics confirmed. But at Harvard, one professor looked at the same data and saw something impossible. The acceleration didn't fit, the trajectory defied gravity, and the chemical signature, it shouldn't exist. Two explanations, both scientific, both cannot be true. This is the story of 3I Atlas. NASA released their analyses. The European Space Agency agreed, a comet. Data from the Hubble Space Telescope showed a teardrop-shaped dust cloud, typical for comets approaching the sun. The ice warms up, it sublimates, gas and dust flow out. According to Starwalk from October 2025, the core is estimated at 0.6 to 5.6 kilometers in diameter. Small, the initial brightness came from the dust cloud, a classic case of misinterpreting early data. Dr. Daryl Seligman from Michigan State University told Newsweek in early November, there is a significant amount of peer-reviewed literature. The analysis from many astronomers worldwide show 3I Atlas is consistent with a natural origin. The explanation is elegant, simple. It fits our understanding of how the universe works. Billions of comets drift through the galaxy. Every now and then, one crosses our system. Case closed. But Professor Abraham Loeb sees it differently. Director of the Institute for Theory and Computation at Harvard, over 200 scientific publications, a man whose reputation is on the line. On the 31st of October 2025, Loeb published calculations on Medium. His analysis, 3I Atlas, showed non-gravitational acceleration at its closest point to the sun. Something besides gravity accelerated the object. For a comet, you'd explain that through outgassing. The gas acts like a small rocket engine. That's known. That's normal. But Loeb did the math. To produce the observed acceleration, 3I Atlas would have had to lose at least 10% of its total mass. That would create a dense, visible gas cloud, something we should clearly see in November and December. According to Newsweek from November 4th, Loeb said, if we don't see that gas cloud, then we have a problem. And then there's nickel tetracarbonyl, a chemical used in industrial processes on Earth. According to Orbital Today from October 22nd, it was found in the spectral data in Nature, extremely rare. Loeb said, there is only one place where that is known to exist, in industrially produced nickel alloys. Here lies the core of the conflict. NASA says the data fits a comet. Loeb says the data doesn't fit well enough. Both are looking at the same measurements, both are using the same mathematics, but they arrive at different conclusions. Why? NASA argues nickel tetracarbonyl is rare, but not impossible in natural processes. The dust cloud explains the brightness. The size estimates were corrected. Everything fits together. Seligman added in his statement, there is no evidence to date to point toward 3I Atlas being an alien spacecraft at this time. That's the standard scientific position. Extraordinary claims require extraordinary evidence. But Loeb counters, if the outgassing was that strong, where is the gas now? Why don't we see a dense cloud? And why did it accelerate exactly when it did? The timing doesn't perfectly match the models. According to Orbital Today from October 22nd, critics say Loeb's approach is too speculative, but even they admit he asks questions that others don't dare to ask. This isn't the first time. 2017, Oumuamua. Loeb suggested, maybe it's a light sail, an alien probe. The reaction was intense. Some called it bold thinking, others called it sensationalism. And here he is again, 8 years later, with a new object, and the same controversial question. The scientific community is divided, not about the facts are the facts, but about the interpretation, about what the facts mean. NASA and most astronomers follow the principle of Occam's razor. The simplest explanation is probably the right one. A comet is simpler than an alien artifact, so it's probably a comet. Loeb argues differently. If the simple explanation has gaps, we must consider all possibilities, even the unlikely ones. Otherwise, we risk overlooking the truth. Both positions are scientifically legitimate. That's important to understand. This is not a clash between science and pseudoscience. This is a dispute within science about methodology, about standards, about the question, when do we have enough evidence? According to Newsweek from November 4th, Loeb also said, he calculated that the European Space Agency should be able to see the gas cloud if it exists. The telescopes are powerful enough, the observations are ongoing. This is the decisive test. If the gas cloud is there, NASA is right. The outgassing explains everything. Loeb was wrong. If the gas cloud isn't there, then it gets complicated. Then we have to explain where the acceleration came from. Without gas, without a known force, that doesn't automatically mean alien technology. There could be a natural process we don't yet understand. Comets in other star systems might behave differently than ours. Different composition, different properties. But it opens a door, a possibility, a space for questions larger than 3I Atlas. Seligman from Michigan State University emphasized in his statement, the scientific method demands caution, peer review, repeated observations. You don't draw hasty conclusions from a single data set. Loeb would probably agree, but he would add, you also don't ignore anomalies. You don't explain them away just because they're inconvenient. That's the fundamental difference in approach. NASA says we have a good explanation, so we stick with it until we're forced to change it. Loeb says we have inconsistencies, so we should keep all options open. Who's right? Maybe both, maybe neither. The data will show. What does this mean for us? It means we're living in an extraordinary time. For the first time in history, we have the technology to study objects from other star systems. 50 years ago, 3I Atlas would have simply flown by, unnoticed, unknown. Now we can see it, measure it, analyze it, and argue about what it is, what it means, what it teaches us. Maybe 3I Atlas is just a comet. That would already be extraordinary. A witness from another star system, a messenger from the depths of space. Or it's something we don't yet fully understand, something that challenges our models. That's not unusual in science. History is full of discoveries that didn't fit the prevailing theories. Sometimes the theories were wrong. Sometimes the interpretations of the data were wrong. Sometimes the truth was more complex than thought. 3I Atlas will continue on, out into the darkness. In a few years, it will leave our solar system forever. We'll never see it again. But the question remains. The debate continues. NASA and Loeb will defend their positions, new data will come, and somewhere in this clash between cautious science and bold questions lies the truth. Maybe we'll find it. Maybe the truth is that a single object isn't enough, that we need more. More observations, more interstellar visitors, more time. But it's a beginning. It's a hint that there's more out there, that the galaxy is full of objects we don't yet understand. In the end, a simple realization remains. The universe is bigger than our theories, stranger than our imagination, and full of things we haven't even begun to understand. Maybe the universe was never silent. Maybe we just haven't been listening properly. And maybe right now we're finally learning how to listen. The truth is out there, but maybe we're not ready for it yet. What do you believe?